Hi everyone, my name is Raina, and welcome to the first episode of Lemonade, my brand new tutorial series teaching you everything you need to know about Sonic 3 Air modding. In this video, we're going to be covering the basics of LemonScript, which is Sonic 3 Air's native scripting language. We'll be covering how to make your own mod template, different variable types, how to make your own custom functions, and at the very end, we're going to be making a custom ability for Sonic. But before we start, if you like this tutorial and want to support me, you can buy me a coffee in the link in the description, or using this QR code on the screen. You got all that? Alright, let's get started. I've provided a template in the description for those of you who want to follow along with the tutorial, but once you have the actual folder open up the mod.json file, and you can see a bunch of information here that we're going to need for our mod. The metadata field is for basically everything that is shown about your mod in the mod selection menu. For the name, that's obviously just the name of your mod. Author description. Unique ID is used by other mod creators to determine your mod. So if your mod shares the name with a separate mod, you're gonna want to have the unique ID to be something different in case both mods have similar ones. Finally, for mod version and game version, mod version can be anything you want. It doesn't even need to be numbers, really. It can literally be letters and stuff. And the game version is just has to match the earliest game version that your mod can run on. So, for example, if your mod uses features only seen in the test build, or in the 2023 version, then you're gonna want to match the numbers on there. However, this game version is a bit of an older one, since this mod will basically work on any of them. We'll come back to the settings here later, but for now, let's move on to main.lemon, where we'll start learning about variable types. Starting us off with the most basic variable types, we have the integer values, specifically unsigned integers and signed integers. Unsigned integers are non-decimal positive number values. This means they cannot have decimal points at the end, and they also cannot go into negative values. The lowest value they can go to is 0, and the highest value depends on the size of unsigned integer you choose. Signed integer types are very much the same, except they can go to either positive or negative number values. So, let's say a unsigned 8 integer. Let's call it number 1. This value has a minimum of 0 and a maximum of 255. And a signed 8, which, let's call this one number 2, has a minimum of negative 255 and a max of 255. Now, these are not valid these are not valid variable definitions, so don't use this for that. But this is essentially what the difference between unsigned and signed integers are. If anyone here has programmed before, you'll already know that integers are stored in hexadecimal format. But if you're not familiar with it, then you're probably wondering, Raina, the fuck are hexadecimals? Well, it's actually pretty simple, if you can wrap your head around it. So, we are normally taught in basic math classes about how to count and work in base 10, which is simple counting from 0 all the way to 10, from 1, 2, 3, 4, all the way up. However, this is standard counting. But however, hexadecimal counts in base 16. This means it starts from 0 and counts all the way up till 9, but rather than going directly to 10, it starts from A, and then it goes to A, B, C, D, E, F, and then 10. What this ends up looking like in hexadecimal is that while this looks like 10, 0x10, it's actually not equal to 10, it actually equals 16. And 0x20 is equal to 32, etc., etc. Now this is important to know for these unsigned and signed integer types, because this corresponds to each of the digits that are on it. U8, U16, U32. Their maximum values is the maximum hexadecimal for each of these. So, for example, U8 has a maximum of 0xFF, U16 has a maximum of 0xFFFF, U32 has a maximum of 0xFFFFFFFF, and U64 maximum of 0xFFFFFFFFFFFFFFFFFFFF. That's a lot of Fs, I know, but this is very important to know because you're going to want to learn which one you want to use depending on how big of a value you need for your integers, because using the incorrect one will cause your mod to be very unoptimized and use a lot of data that it doesn't need. I will go over the more technical side of hexadecimal once I get into binary and binary operators in a future tutorial, but for now let's just move on to other variable types that you need to know. For example, the boolean, which is essentially a true or false value, the float, which is essentially an integer except it can have a decimal point, so let's say 0.1, 2.4, and -3.6. These can all be floats. And a double is essentially a float but with double precision. I personally haven't really found any purpose for this, however, it is useful in the base game and it is used a few times. And finally, we have strings, which is essentially a text value or a string of letters and numbers. So, for example, character underscore Sonic, or character underscore Amy, with these quotation marks, is considered a string, and can be used for things like text rendering. You're probably wondering how we define all of these variables to begin with, since now that I've explained what all of them do. Well, all we need to do in order to define a global variable, which can be used at anywhere, at any point in the game, or any point in your mod, is to type global, and let's just make one of each type. Global U8 number, let's say equals 2. Global S8 number sign, let's say -6. Global wool is pizza, so let's make that false. Global float number floating, let's make that 1.4f. Float values have to have an f put at the end of it to differentiate it from a double. Now a global string, wait no, global double. Let's say number double, and equal that to 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And finally, a global string. Let's say name, and because I'm such a great Amy fan, let's just name it Amy. Now all of these can be called later, and we will be using them here once we start logging them. But for now, let's move on to defining arrays. Now, arrays are essentially a collection of values of any type. For the purposes of the example, let's just use array U8. And in order to find individual values here, you have to just type what the number of value is, let's say 1f, and then followed by a comma, and you can put the next one in. So let's say 0x2f, 0x3f, 0x4f, etc. Now you can do this with anything. If I were to make this string, I could put strings in here. However, it is worth noting that the stuff that you put inside of an array has to match what is here. So if you type array string, you cannot put these values in here. So let me just quickly change this back to a U8. Currently, as of writing this tutorial, arrays can only be constant. Now, constant values are kind of interesting in a way, where when you define a constant, let's say constant u8 static number, and let's say this is 108, for example, right? If I were to then use this in a function, I would not be able to set this value to anything, whereas this value can be changed. This value number can be changed, but static number cannot. The same is true for arrays. Currently, arrays cannot be changed. However, in other programming languages, arrays actually can be changed if you make them dynamic. And I believe this is being added in the future as a feature for Sonic 3 and I will be covering them when that happens. But for now, all you need to know about arrays is that you cannot change them. Everything that is inside of the array is fixed, currently. So, with that all out of the way, let's actually start logging all this stuff in the game. Now, if we put our Lemonade Episode 1 into the mods folder, as you can see here, you can now see it in your inactive mods list, and activate it right now. Now, currently, this does nothing. As you can see, literally nothing is happening. It is just Sonic 3. However, that's because we haven't really changed anything yet. So, here I have this post-frame update function, which is a function from the base game, and we're gonna override it with our own stuff. Now, in order for the game to work still, we need to include base.postFrameUpdate. Now, this is important because what this does is essentially it checks for this function. It runs this function and checks for if there is a function of the exact same name or purpose in the mod below it, and if this is the lowest mod, it runs the base functionality of it from the base game. So, post-frame-update here is running our custom code, which will be here, and then running everything that's supposed to happen afterwards. So let's quickly just use this to log our values to see if they work. So to start off, let's just log equals number. Now number is defined up here as our variable, so if we save this and reload scripts by pressing F11 if you have dev mode enabled, you can see that it now logs 0x2. You may also notice that it is logging the hexadecimal version, so if I were to type 48, for example, it won't actually log 48, it will log something else. Oh wait, the value needs to be reset. Yep, as you can see, it logs 0x30. Now it is worth noting that, as you saw just there, values that are assigned here are only, this is only for when the variable is initiated. After initialization, changing this value and reloading scripts won't do anything. You have to reload the game in order for this to be reassigned. So, let's go and log our other values. Log equals number signed. As you can see, that is -6. Let's say log equals is pizza. Now, you will notice that this logs 0x00 instead of false. And the reason this happens is because a boolean is actually just an integer value, where 0 is false and anything above 0 is true. This is important because it essentially means that any integer value can be used as a boolean. And this can be useful in cases where you have, let's say, options where 0 is off, but everything else needs to be returned as true. Now let's log number.floating. Now you may notice that when we log this, it actually doesn't log it as a hexadecimal. Let's log number double. And as you can see, that is basically exactly what we put there. Except it cuts off at a certain point because I believe double can only have 6 decimal digits, whereas float can only have 3. I may be wrong about that though. Log equals car name. as you can see, we have Amy here, because that's what we put in here. And finally, for arrays, in order to call the value of an array, we have to type the name of an array, the name of the array, as well as some square brackets, and the number that we put in within this will correspond to the number here, to the number slot of this array. It is important to note that counting in arrays, and counting in general, within LemonScript, and most coding programs, and most coding languages, I mean, it stops at 0 instead of 1. So if you want to call 0x1f, you would have to put 0 here. And as you can see, 0x1f. If I do 1, it will do 0x2f, and so on. Let's say 3, 0x4f, which is right here. Now, if you call something that is outside of the range of the array, it will just default to 0 and just log 0. So that is important to know as well. Now, without further ado, let's move on to the next part of the tutorial. Now, you may have noticed, even with the small amount of stuff that we've put inside of this LemonScript file, it's already starting to get a little bit big. And obviously putting all of your code within one singular Lemon file is kind of inefficient in terms of trying to organize stuff. So what a lot of modders do, including myself, is include other script files which are held within the scripts folder that the main Lemon file is in. Now, what this will do is it will take the contents of that file and act as if those are within the main.lemon, which will allow that code to be run directly after the main.lemon file's code is run during compilation, effectively linking all of them together. So in order to include our scripts, let's quickly take a look at the scripts folder provided in the template, and you'll notice two things here, an abilities.lemon and a subfolder with debug logs in. Now, we're going to want to move our post-frame update stuff into debug logs, just for the purposes of this tutorial. In order to do that, we need to include the debug logs lemon file. So to do that, we can type include, then we'll put the name of the folder, which is subfolder, slash, and then the name of the lemon file, which is debug logs. Now, if we reload scripts, you'll see it has done literally nothing, but that's because this LemonScript file is empty. So let's quickly move this post-frame update function into the other script. And as you can see, the script works perfectly. Now, let's move on to the final part of this tutorial, where we will be creating our very own ability. In order to do this, let's first include the abilities.lemon. Because abilities.lemon is in the same folder as main.lemon, we don't actually need to put the folder name, so we can type include abilities and reload scripts. And now we can look at what's in here. So, for this custom ability, we are going to be making something called the amplidash. What this does is it amplifies the current velocity by a multiplier in the settings. Before amplification, pause in place for 20 frames, then flash the screen to white before amplification. During charge, play SFX spin dash charge, and during release, SFX spin dash release using play sound function. Perform charge in a custom function for organization. So, without further ado, let's get into this. So to start us off with this custom ability, we're gonna take a quick look back into the mod.json file that we started this tutorial with. Here we have this settings component, as well as the name of the mod that of the name of the mod settings that we are going to do. This will essentially print this ID into the settings.json file located in your app's directory, and this will allow your mod settings to be saved. Now, the internal name is just a name used by the settings.json to identify this setting, so it can be anything that you want. The display name is what the name actually is displayed as in the options menu. The category is just what category it is, so if I were to make another option and change what category is, it will be split off into its own separate section. And finally, we have the variable intensity, which has to be the name of a global variable in the scripts. So let's quickly copy this and define a global U8 called intensity. So, it has to be a global U8 to my knowledge. You might be able to use something else, but for safety purposes, I would just recommend using global U8, because I'm unsure of what would happen if you use something else. Now, this default value just changes what value the option is set to when first initializing the mod. In my case, it's 0x, in my case it's just 1, which is times 1. And here we have the actual options. In this section, you have the ID, you have the sort of ID for the option. This is the number value assigned to each option, though it can either be hexadecimal or regular integer, it doesn't really matter. And here, you have the name of the option, which is shown in settings. If we quickly go into the options here, you can see that intensity is here, and the name of the options are displayed within the arrows. Let's just set this to 1. And get back to the abilities.lemon file. I just quickly went and grabbed this global.whiteFlash timeout value. This is used for screen flashes in the base Sonic 3 and it's what we're going to be using for the white flash before the amplification. Now, quickly, here we have this function called sonic.pressJump in midair. What this function does is essentially it enables Sonic's mid-air ability. Since we are calling the base function, it will be calling what the base game normally uses, which is the insta-shield, like this, and the drop dash. However, since we don't want that, we are going to be removing the base call here, so that the function does absolutely nothing. And as you can see, it works. Sonic now does nothing. So, when you press the jump button, you want to pause in place for 20 frames. So let's quickly define a new global variable here, global U8 ability frames. You don't actually have to type =0, you can just define it as this, and by default it will just be 0. So then, let's say when he jumps in mid-air, we want ability frames to be 20. And here, let's quickly log ability frames. Now, as you can see, ability frames is set to 0, but now it's set to 0x14, which is 20 in hexadecimal. So now, we want to have the ability frames be counted down, essentially. So, before, when I said that you can use U8 values as, unsigned 8 integers as booleans, this is where this is going to come in handy. You can type if ability frames, and then let's say sonic.update amplidash. Now, this is calling a function that doesn't exist currently, so we want to define our brand new function by typing function void sonic.update amplidash. And all we want to do here is minus the amplidash by, the amplidash ability frames by 1, and log the ability frames here. Now, ability frames minus is essentially the same as typing ability frames equals ability frames minus 1. So, I will be covering more niche things like this in a future tutorial. So now let's quickly test what we've done. And as you can see, the dash now happens. So I realized that I had my sound turned off, so I quickly just turned that on for this specific part. We want to use the play sound function here to play the sfx_spin-charge. So real quick, let's just put sfx spin-charge in here. Now what this will do is it will determine what it will play the sfx spin-charge sound, which this is a constant defined in the base game that corresponds to a U8 value, which is used as a sound ID in the base game. So here we have play sound sfx charge. So let's quickly test if this works. And yep, there it is. So, moving on, we have the next thing. Let's say during charge, play sfx spin-charge, during release, play sfx spin-release. So, in order to play this sound, the final sound, let's quickly type here if ability frames equals 0, because by this point ability frames would have subtracted. So from here, ability frames will equal 0. So if it equals to 0, play sound and sfx spin-release. And as you can see, now, what this indentation here does, let me just pause this. You may have noticed that in here and here, I put this little indent, which I did by pressing tab. And what this does is this if statement now specifically encloses this one line. If I were to put an indented thing here and say car.velocity.x equals 0, this would be considered invalid and wouldn't actually do anything. Well, it would, but it doesn't happen at specifically this point. This is essentially the same as doing this, which means that everything here is not enclosed. So, if I were to then enclose this within curly braces and do the exact same thing, as you can see, velocity x isn't actually stopped until the very end. However, here we want car velocity x to be amplified. So let's multiply this by intensity. And car.velocity.y times equals intensity. Now, just like minus minus, this is essentially the exact same as typing car.velocity x equals car velocity x times intensity. It's essentially a shorthand for that. And if the ability frames is not 0, we want to set car.velocity.x to 0, car.velocity.y to 0. Now, you may already notice a problem with this code, but I'm going to test it anyway to show you what that problem is. As you can see, Sonic doesn't go anywhere. Even if I were to set intensity to 3, Sonic doesn't actually get teleported anywhere, and the reason why is because at this point, car.velocity_x and car.velocity_y are set to 0, so 0 times intensity, which is 3, is also 0. So in order for this to work, we are going to want to first back up velocities. So this means we're going to need to create two new things. Global S16 velocity x backup. Let's say velocity x dot backup. and global s16 velocity y dot backup. Now, let's make it so that when you press jump, velocity x dot backup equals car dot velocity dot x, and velocity y dot backup is equal to car dot velocity dot y. And to finish this up, we are going to want to set this instead to equals velocity x backup times intensity and velocity y backup times intensity. So, to finish this off, we're going to add the global white flash timeout to do the white flash. And let's set it to 5 frames. Now, let's try our new ability. As you can see, it's working basically exactly as intended. It is kind of janky because the ability is purely for tutorial purposes, but it means you can do cool stuff like that. And finally, to wrap things all up, we're going to want to remove all of the logs that we have been putting there so that it doesn't show up when people actually play the game. So here, we can just delete everything, because it's not necessary anymore. Or, if you want to keep these logs for future use, which is what I like to do, you can type /*, and then at the very end, */. And what this will essentially do is it acts as a double slash comment for every single line within them. So all of this does nothing now. And in ability, we can type // here to comment out log equals ability frames, which will make that code not run anymore. And as you can see, once you reload scripts, it no longer logs. And we can now use our amplidash in peace. And that wraps up everything for this tutorial. If you like this video and want to see more, be sure to hit the like button, as well as subscribing and hitting the notification bell for when new videos come out. And if you have any suggestions for any future tutorials that you would like me to make, you can leave them in the comments down below. And with all that out of the way, thank you for watching, and I hope to see you all next time. Bye!